Hello students, how are you all? I hope you are doing absolutely well. So, in our previous topic, we have discussed about the balancing of the redox reaction and we have learned about the first method, that is oxidation number method. Now in today's lecture, we will deal with our second method of balancing the chemical equation, and the name of the method is ion electron method, or we can also say that half reaction method. So, our second topic is ion electron method. This ion electron method is also known as half reaction method. This method is basically known as half reaction method, and it is based actually on the principle that electron lost during the oxidation half reaction will be equal to electron gained during the reduction half of the reaction. So what is the basic principle involved here? The principle involved here is electrons lost during oxidation reaction will be equal to electrons gained during reduction reaction. So this will be the basic principle involved in this half reaction method, that electrons lost during the oxidation half reaction will be equal to electrons gained during the reduction half of the reaction. So this will be the basic principle of the half reaction method. Now we will learn few steps of balancing the equation by ion electron method, and our step number 1 will be, is write the equation in ionic form. We will write the equation in ionic form. Now, our step number 2 will be identify the elements which are getting reduced and oxidized. Which are getting reduced and oxidized. So this will be the second step of our balancing, that we have to identify the elements which are getting oxidized and which are getting reduced. Now our step number 3 will be, in our step number 3, what we are going to do, we will split the reaction into two halves, that is oxidation half and reduction half. Split the reaction in two halves. We will split the reaction into two halves, and the first one is oxidation half reaction and second one is reduction half reaction. Oxidation half reaction and reduction half reaction. So this will be the third step, that we will split the equation into two parts, that is oxidation half and reduction half. Now what will be our step number 4? In our step number 4, In step number 4, we will try to balance the number of ions on both the side of the equation. Balance number of electrons on both equation. Now, we have 2 steps more, that is step number 5 is, if the reaction is carried out in the acidic medium, what we will do, we will add hydrogen atoms or hydrogen ions on the hydrogen deficient side, and if the equation is carried out in the basic medium, we are going to add OH minus ions on the equation side, and simultaneously we will add H2O molecules to balance the both side of the equation. So now our step number 5 will be in our step number 5, what we are going to do, in acidic medium, if the reaction is carried out in the acidic medium, add H plus ions or H2O on hydrogen deficient side. But we have to balance the H atoms on both the side of the equation. But if the reaction is carried out in the basic medium, we have our next step, that is step number 6. In our step number 6, if the reaction is proceeding in basic medium, what we are doing, we will add OH minus ions to balance oxygen and H2O accordingly. So this will be our step number 6, in which we are going to add OH minus ions to balance hydrogen and oxygen. Now our hydrogen and oxygens are balanced, we will add oxygen and hydrogen according to the reaction. Now what we will do, we will add both the half reactions. So our step number 7 will be, add both half reactions and cancel the common terms. So what we are doing in this last step, we will add both the half reaction, and if there are any common terms in both the side of the equation, what we will do, we will cancel both the side of the equation. So these are basically the 7 steps that we will analyze in the ion electron method. This is quite different from the oxidation number method. So now we will understand this with the help of an example, but before that you can copy it from here. So we will understand these steps with the help of a simple example. So we will discuss the ion electron method with the help of an example. So we have example in this category. So our method's name is ion electron method. So in this method we have an example. Cr2O7 minus 2 Fe plus 2 H positive gives Cr plus 3 Fe plus 3 plus H2O. So this will be our example and we have to balance this equation. So what we will do, we will follow the similar steps and try to balance the equation by ion electron method. So our step number 1 will be write the skeletal equation. So our step number 1 is write skeletal equation. So the skeletal equation is the question provided itself. So the skeletal equation is Cr2O7 minus 2 Fe plus 2 plus H positive gives Cr plus 3 Fe plus 3 plus H2O. So this will be our skeletal equation. What will be our step number 2? We have to identify the oxidation number of individual element in the reaction. So our step number 2 is write oxidation state. So in our step number 2, what we are going to do is we will write this oxidation state of each element. So firstly, we are provided with Cr2O7 minus 2. In this case, the oxidation number of oxygen will be minus 2, and I am calculating for the chromium by the oxidation number method here. So the oxidation state will be calculated as chromium 2 X 7 into minus 2 equal to minus 2, 2x minus 14 equal to minus 2, 2x is equal to 14 minus 2, x is equal to 12 upon 2, that is equal to 6. So the oxidation number of chromium in case of the chromate ion will be 6. So the oxidation number will be calculated as follows. This is oxidation number. So for the chromium, the oxidation number is plus 6 whole power minus 2. Fe oxidation number is plus 3. Hydrogen oxidation number is plus 1. Chromium oxidation number is plus 3. Iron oxidation number is plus 3. For H2O oxidation number is for oxygen is minus 2, and for hydrogen the oxidation state is plus 1. So this will be the oxidation number of individual element in step number 2. So we have written a oxidation number of each element in the equation. Now we will follow our step number 3, and what we will do in this equation, we will identify the oxidizing and reducing agent in the cases. So our step number 3 will be identify the species which are oxidized or reduced. So what we will do here, we will identify the species that are oxidized or reduced. So I am writing the equation again here. So this is the reaction. I am writing the oxidation number above it. Oxidation number is plus 6, minus 2, plus 3, plus 1, plus 3, plus 2, plus 1, minus 2. So this is the oxidation number of individual elements in the reaction. Now what we have observed here, chromium is having an oxidation number 6, is reduced to plus 3. It means there will be the reduction in oxidation number. There is a reduction of oxidation number. And what will happen in case of iron? Fe plus 3 lost 2 electrons and Fe plus 2 is formed. So there will be the increase in oxidation number. So what we can say, if there is an increment in the oxidation number, the reaction is known as oxidation half reaction, and the reaction which is having a reduction in oxidation number, we can say that the reaction must have a reduction half reaction. So how there will be the reduction of oxidation number? There are two chromium atoms, so we can say that the oxidation state is plus 6 into 2, that is equal to 12, and it is reduced to plus 3. So 12 getting reduced to plus 3. Now we will follow our step number 4. Our step number 4 will be split the reaction in two halves. Now we will determine that which reaction is oxidation half reaction and which reaction is reduction half reaction. So here I am writing the reaction, that is Fe plus 3 gives Fe plus 2, and our second reaction is Cr2O7 plus 6 minus 2 is giving Cr plus 3, that is 2. If I am balancing it, there will be 2. Now we can see here there is a reduction of oxidation number and there will be the increment of oxidation number. In case of chromium, there will be reduction. In case of iron, there will be the increment in oxidation number. So we must say that this reaction is oxidation half reaction. And this is reduction half reaction. So this will be our oxidation half reaction and this will be our reduction half reaction. Now what we will do, we will calculate the number of ions in both the side of the equation. So if you want to copy it, please copy it from here. So we can proceed to our step number 5. Now our step number 5 will be we will balance the number of electrons. We will balance electrons on both sides. So we have our first equation, that is Fe plus 3 gives Fe plus 2, and our second reaction is this is our second reaction. So what will happen in case of the oxidation? There will be the loss of electrons. So I can write 1 electron here. Now what happens in this case? We have oxidation state plus 6. So we are having 2 Cr plus 3. We have seen here there will be the difference of 2, that is 2 into 6, 12, and there we have 6 electrons. So what we have to do here, we will balance the equation like this. 6 electrons give Cr plus 3. Why I have added 6 electrons in this equation? Because chromium is provided with oxidation number plus 3 and chromium will having a 2 molecules, 2 atoms here. So 2 into 3, 6. So this will be the oxidation half reaction and this will be our reduction half reaction. Now our next case will be balancing the number of atoms by hit and trial method. So we can observe here Fe is 1, 1, chromium is 2, 2. Now we will balance the equation as per acidic and basic medium. So we will balance the number of hydrogen and oxygen atoms. So for doing this, I am equating the equation and adding both the equation. So our step number 6 will be add both reactions. So if I'm going to add both the reaction, what I will get here, Fe plus 3 plus Cr2O7 plus 6 electrons gives Fe plus 2 plus electron plus 2 Cr plus 3. I have added both the equation. Now you can observe from here there are 7 oxygen atoms. So what I have to do, I have to add 7 H2O atoms or molecules in the right hand side of the equation. So we are proceeding to our next step. Our step number 7 will be Fe plus 3 plus Cr2O3 plus 6 electrons gives Fe plus 2 plus electron 2 Cr plus 3. Now here we have 7 oxygen atoms, Cr2O7. So I am adding 7 H2O on this side. So what I am doing here, I am adding 7 H2O this side because I have to keep the oxygen atoms 7. Now what you have observed here, 7 into 2, that is equal to 14. 14 H plus ions is present in the product side of the equation. So we have to balance these 14 in this side. So our step number 7th again will be Fe plus 3 Cr2O7 plus 14H positive plus 6 electron Fe plus 2 plus electron 2 Cr plus 3 plus 7H2O. Now you can see here the hydrogens and oxygens are completely balanced, but we have skipped with our first one step in this equation. We have to equate the number of electrons in this equation. So what I have to do here, I have provided with 6 electrons and I have to cancel this 6 electrons with this 6 electrons. So I am multiplying this equation by 6. So what we will get here, this equation is Fe plus 3 gives Fe plus 2 plus electrons. So I am multiplying this equation by 6. So what I am getting here, Fe plus 3, 6 gives 6 Fe plus 2 plus 6 electrons. Now this equation will be the right hand side of the equation. So what we will get finally, we will get here Fe plus 3, that is 6 plus Cr2O7 plus 14H positive 6 Fe plus 2 plus 2 Cr positive and 7 H2O. So what will happen in this case, 6 electrons will be substituted here. 6 electrons will be cancelled by the 6 electrons because our first aim is to balance the electrons. So what we will get in the product side, we will get the equation this. So I must say that this equation is a complete balance equation by the half reaction method or ion electron method of a redox reaction. So by following these simple steps, we can balance the equation in the same manner. So this topic is very important for you from your competitive exam point of view. This is not essential for the board exam point of view. So this lecture is over for today. We will deal with many more topics in our next session. Thank you so much and have a nice day.